Geometry Chapter 10, Lesson 3. Now that we understand some of the things that we can do in the regular polygon in creating these triangles, let's look at the formula that we can use to determine the area of any regular polygon and then show you how it works. The formula itself is pretty simple. An area of any regular polygon is equal to 1/2 A times P. And like any formula, we need to know what the different letters represent, and then as we go to the figure, we know what we're looking for. The large A on the left represents the area. The A represents the apothem. Now remember, that's the segment that is perpendicular to the side of a polygon drawn from the center. And then the perimeter, and the perimeter is a word we used before. The perimeter is the distance around the outside of a figure. And so what we'll have to do to find the perimeter is to add all the sides together. So it's important to know what the variables represent. And remember, the value of any variable can be determined if I know all of the other ones. So if I'm given the area, I can figure out the perimeter as long as I know the apothem. Okay, so let's do a couple of examples, a couple where they give us the apothem maybe, and then a couple where they don't. We maybe have to go on a little search for ourselves. So determine the area of this figure here. Well, the area, because it's a regular polygon, I start with the formula. And now I go to my figure and figure out, or try to gather the information that I need. The little a represents the apothem, which is a side, or a segment, drawn perpendicular to a side from the center. And in this case, the apothem is given to me as a 12.3. So I can just substitute that right into my formula, 12.3 units. Then I need the perimeter. Now, they give me the length of one side. That's not the perimeter. That's all of the sides added together would be the perimeter. But because it's regular, all I have to do is take this one side and multiply it by how many sides I have. And in this figure, I think I have 10 sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 sides. All of them are 8. So 10 times 8 would be 80. So the perimeter is 80 units. So I've substituted in my formula. I simply need to do the arithmetic. So I can take half of the 80, because that's an even number, that's going to be 40, and then I do 40 times 12.3. 40 times 12.3 ends up being 492, and then I have units times units, which would be units squared. And so this would be the area of this regular polygon. We'll check our answer. We have 492. I have inches squared here, but they don't give me the inches. So, okay, so again, the formula is fairly simple. We just need to go to the figure and then find the values that we need. Determine the area of this regular polygon. Again, I notice it's regular polygon, so I choose my formula. 1/2 is equal to A times P. The area is equal to 1/2 the apothem. As I go to my figure now to look for the apothem, I realize it's not given to me. That means I'm going to have to figure it out. The perimeter I can get, they give me the length of one side as 10, so the perimeter would be however many sides I have times this number. So counting the sides, I have 1, 2, 3, 4, 5, 6 sides, though, so my perimeter, is 60. So I have 1/2, the apothem I don't have yet, the perimeter I have as 60 millimeters, so I'm going to have to figure out the apothem. And we're going to use what we learned about the radii and the apothem in a figure. So if I go to my figure here, we remember that if I draw 2 radii from the center, okay, it creates this isosceles triangle, and this angle I can determine by taking 360 and dividing it by how many sides I have. In this case I have 6, and so that is equal to 60. So this angle right here is a 60-degree angle. Now that doesn't help me directly yet. If I draw the apothem, which is the length that I'm looking for actually, which is perpendicular, this is the length that I need for my formula. That's the one I'm trying to figure out. I know that when I draw the apothem, it cuts this 60-degree angle in half. So that means this angle here on the little triangle on the left is a 30. I also know that when I draw this apothem, it cuts this side in half. So I know the length of the entire side is 10. That was given to me here. It's regular and all the sides are the same. So that means that this is now 5. So what I have now is a 30, 60, 90 on the left, where I know what the shorter side is, and the apothem is the one I want. The apothem is my longer side. Well, my longer side I can get from my 30, 60, 90 by multiplying the shorter times the square root of 3. So this side is 5 times the square root of 3, so that's my apothem. That's the side or the segment that goes from the center perpendicular to the side. So you can see how putting all that together, what we worked with in the previous videos, allows me to calculate an apothem that wasn't there because I need that for my formula. Now that I have all the pieces to my formula, I simply finish off with the arithmetic. I can take half of the 60, that's a nice even number, so I'll do that. So that's a 30. And then I can multiply this 30 times this 5 because both of those are non-radical numbers. And then I have the square root of 3 left. And then I have millimeters, I should put millimeters here. Millimeters times millimeters is millimeters squared. So this would be my exact answer, or my answer in simplest radical form. If I went ahead and had to multiply that out, this would come out to be 260 millimeters squared. So again, we start with the formula for the apothem, or for the area, excuse me. As I go to the figure, I need to find these two values in the figure. If they're not given to me, then I want to use what we learned in the previous lessons, creating this triangle in the inside, finding the measure of the big angle, drawing the apothem, which cuts that big angle in half, and creates right triangles where I can use either Pythagorean theorem, or in this case what I know about a 30, 60, 90, or if it happened to be a 45, 45, 90, or if none of those, I could use trigonometry even to determine the length of this perpendicular segment, which is the apothem, which is what I need for my formula. Okay, so again, the formula is not too difficult. Remembering how to figure out what I need for the formula, that becomes the challenging part. But the more you do this, the easier it becomes because you'll know what you're looking for and you'll know how to get it. Another example here, and here's a case where we have a square where we could use, because it's a parallelogram, we could use the formula base times height if I knew what those were. We could also, because it's a rhombus, use the diagonal times the diagonal times 1/2, that formula, if I knew those, but lots of bells today. We want to use the formula for a regular polygon so you can see how to use this. So again, because it's a regular polygon, I want to start by writing down my formula. And as I go to my figure, I know what I'm looking for. I'm looking for the length of the apothem, which is perpendicular to a side. Now be careful here, this is not the apothem. This is a radii. It's drawn to the vertex. It's not drawn perpendicular to the side. This is the length I need. That's my apothem. It's not there, so I'm going to have to figure it out like we did on the previous problem. Another twist to this problem is that I need to know the perimeter, and I don't know the length of this side. So I'm going to have to figure out the length of the side in order to find the perimeter as well. So I'm going to have to do two things in order to find the value that I need, or the values that I need, the numbers I need to substitute into my formula. Okay, so remember, the apothem is what I'm looking for, and then the length of this side is what I'm looking for. Well, we're going to start by drawing our two radii, because when I draw two radii, I can figure out this angle by doing 360 divided by the number of sides. In this case is 4, so that ends up being 90. So this angle here is a 90-degree angle. When I draw my apothem, it cuts that 90-degree angle in half. So this is a 45-degree angle, which means this right triangle on the left is a 45, 45, 90, which allows me to use what I know about the 45, 45, 90 to figure out what I need. Now, I need to know what the length of this side is here. That's my apothem. Now, as I look at the 45, 45, 90, this 6 centimeters is my hypotenuse, and this is a leg. You remember from the 45, 45, 90, but if I take a leg and multiply by radical 2, that gives me my hypotenuse, which in this case is 6. So the leg in this case happens to be the apothem that I'm looking for, so let me just change that out. So I'm going to go ahead and use this to determine what the apothem is. Now my apothem is the square root of 6 then divided by the square root, no, not square root of 6. 6 divided by the square root of 2. So I have my apothem. And again, I don't need to rationalize this denominator here because I'm going to use this value to do another calculation. The only time I have to rationalize is when I get to the end. So I still need the perimeter. So how am I going to figure out that? Well, I can figure out this part of the side because it's the other side of my 45, 45, 90. So this leg from here to here is 6 square root of 2. Now you remember when we draw this hypotenuse, or this apothem, it cuts this side in half. So if this side is 6 square root of 2, then this side is also 6 square root of 2. So the length of one side would be these two added together. Because the denominators are the same, I simply add the numerators. So one side is 12 square root of 2. That's the length of one side. Now I need the perimeter, so I need to add 4 of these together, or if I just multiply this by 4, that will give me the perimeter. So I'm multiplying fractions, so numerator times numerator is 48, and then radical 2 times 1 is radical 2. So my perimeter is 48 divided by the square root of 2. So now that I have all of my values, and actually I didn't put centimeters in here, I should put centimeters in here. Now I simply multiply all this together. Now I can multiply this, or I can reduce these any way I want. So this 2 can reduce with, let's reduce this 48, make it smaller because it's an even number. Let's make that 24. Now you remember a radical 2 times a radical 2 in my denominator, these two numbers become a 2. And now I have a non-radical number that I can reduce again. 2 reduces with 24, making that 12. So my denominator now all reduces to a nice 1. So all I have to do is multiply what's left. This 6 times this 12, which is 72. And then the centimeters times the centimeters is centimeters squared. So the area of this regular polygon, which happens to be a rhombus, which happens to be a square, is 72 centimeters squared. So this was a case where I wasn't given the apothem or the perimeter, but again, by creating these right triangles inside, using what we learned from the previous 2 lessons, we can determine what we need, the apothem, and then the perimeter by finding the length of the side and then multiplying it by how many sides I have. I know that was a lot of work, but again, once you do more and more of these, you get the idea. We can go ahead and get better at those. So let's do one more example. Again, I'm given a triangle, which I can use 1/2 base times height, but I'm not given base and height here. And this lesson's about regular polygons, so we want to use the regular polygon formula, which again, the area is equal to 1/2 the apothem times the perimeter. So I need to go to my diagram and find the apothem and find the perimeter. Again, this radius is not the apothem. As I said, it's a radius. So I'm going to have to create my triangle and then use what I know about those triangles to determine the apothem and the perimeter. Now, this is drawn up here. I'm going to draw it down here just so it's not upside down. So all these radii are going to be equal. So this is 4. Okay, and if I draw this. So I can determine the measure of this angle of this isosceles triangle by doing 360 and dividing by the number of sides is 3, so that makes that 120. So this big angle is 120. When I draw my apothem, it cuts that 120 in half. So we divide that by 2, so that's a 60. So this angle is a 60-degree angle. Now again, this perpendicular side is my apothem. I'm going to have to determine what that is. I'm going to have to determine what this is because that's half the length of my side, and that's going to help me find my perimeter. You remember our characteristics or properties of a 30, 60, 90. The 4, that is the radii, is the hypotenuse, and the hypotenuse, remember, is the shorter leg times 2. So this is opposite the 30, so A, which is the shorter, times 2 gives me my hypotenuse. So using some algebra and solving this, I get an apothem of 2. So I have my apothem, and that's a measure of 2 inches. Now, to find my perimeter, I can use the small triangle to find out half the side, then I can figure out the rest. So this side is the longer. I now know that this is 2, and the longer side, you remember, is the shorter side, which is 2, times radical 3 is equal to the longer. This is my longer. So from here to here is 2 square root of 3. Now I need the whole side so that I can figure out the perimeter. So I need to add 2 radical 3 to itself. So 2 plus 2 is 4, and then there's still radical 3. I don't do anything with those. So one side is 4 radical 3, and I have 3 of those to get my perimeter. So my perimeter is 12 radical 3. So the perimeter of this figure is 12 radical 3 inches. Now that I have all the values for my formula, I can just do the arithmetic. So I can take half of this 2, which is 1, and 1 times 12 radical 3 is 12 radical 3. Inches times inches is inches squared. So this would be my answer in simplest radical form, or my exact answer for the area of this triangle, using the formula for a regular polygon. A is equal to 1/2 A times P.